In this video, we're going to be looking at series instead of sequence. So, definition: when the terms of a sequence are added together, the resulting expression is a series. A series can be finite or infinite. For example, a finite series might look something like this: 2 plus 4 plus 6 plus 8. So that's the same sequence we had before, but instead of commas in between each term, now we have plus signs. For an infinite series, we might have something like 2 plus 4 plus 6 plus 8 plus ... and it continues on forever and ever without stopping. It is an infinite series. You can use something called summation notation to write a series. For example, the two series above can be written in summation notation as follows here. So we'll write that out. Here's what it looks like. We're going to draw a Greek letter sigma. Okay, it's kind of like a really sharp or crooked E. Okay. Now on the bottom of it, we're going to put I is equal to 1. Okay. Now we're doing that, we're saying this is the index of summation. Okay, as it says here, index of summation is I. The lower limit of summation is 1. What that means is that we're starting with the first term of this particular sequence as we're going to add them up in our series. Now, if you notice, there are 1, 2, 3, 4 terms in this finite series. So my upper limit of summation is going to be a 4. So this means take all the terms from the first term to the fourth term and add them up. Now, the other thing I have to write is I need to write my rule. And my rule for this particular sequence, if you remember from before, it was 2 times n, or in this case, we're going to put I because that's a variable we happen to use in summation notation. So it doesn't mean I, the imaginary number. We're just using it as a variable in this case, I for index. Okay, maybe a little bit confusing because we've used I for something else before, but we can use any letter. In this case, we'll start with I for index. So this would be summation notation for the finite series here. The only difference is if I were to write the summation notation for the infinite series would be, I'd still have my sigma symbol. My I in the bottom would be I equals 1, saying start at 1 with I as the independent variable here. The rule is 2 times I. The difference is instead of stopping after the fourth term and adding them up, I continue on to infinity. So from 1 to infinity with this rule for each term, add up all of those terms. There's my series in summation notation. This summation notation business is often referred to not as summation notation, but instead it's called sigma notation because of its use of the Greek letter sigma, which is written like you see here. If we're asked to write a series using sigma notation, usually I'll refer to it, one of the tricky things I need to do is I need to figure out what the rule is for this particular series. Okay. Now we can always start by just putting our sigma symbol. Okay, here we go, sigma. All right, and let's go with n equals 1 through, I got to figure out how many terms there are. The ellipsis in the middle means that there's some terms that were left out. So how do I come up with these particular numbers? 1, 8, 27, 64, 729. And again, if you don't recognize patterns very well, this can be a little bit difficult. But if you recognize this as being the perfect cubes, remember this is the first term, second term, third term, fourth term, etc. How do I turn 1 into 1, 2 into 8, 3 into 27, 4 into 64? Well, take that particular number and cube it. 1 cubed is 1, 2 cubed is 8, 3 cubed is 27, 4 cubed is 64, etc. So there's my rule, n cubed. Now, what is the upper limit of summation? Well, what did I cubed to come up with 729? Well, if you do a little math or you check out your list of perfect powers, you'll notice, I believe, that 9 cubed is 729. So that must mean that we're adding up all the terms from the first term through the 9th term for the series with this particular rule, n cubed. There's my sigma notation for that series. We'll do a second one. Start with my sigma notation. Now, one thing I notice here is this is an infinite series, so I'll go and put the infinity symbol on the top. So I got part of it ready to go. I'll use k this time. So k equals 1 on the bottom. So from 1 to infinity. Now, let's figure out the rule. One thing I notice is there's a 1 on top for each term. Okay? We'll put 1 on top of something. So doing that, now I just have to figure out how do I get the bottom. Well, if I imagine that this is 1, so I got 1, then 2, 4, 8, etc. Next is probably 1/16th and then 1/32. Each of those is, I'm multiplying by 2 every time, which means I'm probably taking 2 to some particular power. Okay, so 2 to the k. Now, the one thing to keep in mind is that if I chose to start at 1, that means I plug in 1 for k in this first term. Well, 2 to the first power is 2, but I don't have 2 here. I have 2 as the second one. So what I have to do is I have to back up 1 in my exponent. Okay? What that means is when I plug in 1, 1 minus 1 is 0. 2 to the 0 equals 1. So that's going to work out. So if I find my first term, I plug in 1 to find my first term, it gives me 1 for the denominator. So the denominator of this is going to be 2 raised to the k minus 1 power. There's my rule. And again, you can check that. If I want to find the fourth term, I plug in 4. 4 minus 1 is 3. 2 cubed is 8. That works out okay. So here would be summation notation with a rule for this infinite series.